Hey everybody, thought I'd do another Geek Tips video. It's been a pretty long time since the last one I did. I got a lot of good feedback, so please keep giving feedback about what you'd like to see different. I hadn't done one for a while because couldn't tell. I've had a pretty serious accident and broke both my neck and my back in April. So I've been working from the couch. Didn't really feel like doing anything from the couch. So I decided getting ready to make some soft jaws in my garage. I got a Haws out there that's pretty nice. And I got a Chick one lock vise setup. And I plan on making some Chronicle parts. We call them Chronicle parts inside a Toolpath because, we feel like, making real parts is a good way to test the software. And I need some soft jaws for that. So Carol's been out there helping me make those, and did the programming and thought it'd be a good part to share. So let's get straight to it. Here's the part. So it's got kind of a tight undercut. It's got kind of a, we're going to use a Harvey Keyseat cutter to get in there. Other than that, it's a real simple part, but this poses some problems. I broke maybe I'll show a picture of it, but I broke a tool just trying to kind of plow in there. To be honest, I just made a mistake and forgot. I really, these tools are expensive and don't like to just go plowing into corners. So I did a 2D adaptive is the right way to do that. So I'll show you, the problem is Fusion has kind of a known problem they've been struggling with for years. But when you're using a Keyseat cutter with an adaptive toolpath, often it'll retract while it's still under the cut. So I'll show you how I deal with that. If nothing else, the video hopefully will be worth, how to handle that. And then I'm also going to show you how to under chamfer this. I do have a 90-degree side chamfer mill, but we're just going to use one of my thread mills for this. I'll show you how I do that. And I think that's really the geeky part of this, but then you'll get to see the kind of walkthrough of Toolpath. So with that, let's get started. So first thing we can do is we have the Toolpath plugin. We could just hit send and send that sucker straight to Toolpath. Now what this does is it's going to define your setups, right? So based on your preferences, your cut config and your stock preferences and stuff, it'll define your setups. I sent one a few minutes ago, so if we go take a look at that, there's one already being worked on here. Actually, I'm too impatient. I think that is the same as this one, maybe not. So anyways, this is going to define the stock based on what's in my preferences. In this specific case, I already have I have the stock I know I want to use, and I kind of want to micromanage it a little bit, tell it exactly where the work coordinate is, exactly what the stock is. So let's just go to the manufacturer tab, go to the setups, and the first thing I'm going to do is dock that over there. I like to set up my work coordinate. If you guys didn't know about this, if you click the little white dot, you can just kind of move your work coordinate system around. You can also click the head of your arrows to flip them, or you can click them and reorient them to different surfaces or line segments or whatnot. Anyways, we'll move that sucker down there. We're going to make this the stock box point. So this is, I like my work coordinate system to be down there. It's, against the parallel surface, against the Y fixed side of the jaw, and against my stop. So on the stock, I know exactly what size the stock is, so I'm just going to go define the stock size, 6.25 by 2.25, almost forgot it there, and then by 1.25. And then I don't want to do any rounding because I know exactly what the stock size is, but then I do want to, there's a couple ways. I can either offset it in the negative or offset it in the positive. Now, one perspective would be, I only really want to knock off like 10,000ths of an inch for a finish pass on the top. The other perspective is maybe I want to offset it on the negative because I'm holding on to it with these little Mighty Bite Talon grippers. And I know I need at least 125 thou to hold. Well, actually, I only need like 90 thou to hold on to. But I usually do about 125. And I just have to remember 125 minus the 90 that I need leaves me, what, 35 thou. So as long as I don't go below the part by 35 thou, I'll be good. So on the post processor setup, we're going to do 10001. We'll call this first op. And then on the work coordinate system for any real new Fusion users, 0 and 1 is equal to G54. 2 is 55, 3 is 56. I'm going to use 54 and 55 on this. Now, I never use 0 because if 0 and 1 is equal to 54, I leave 0 for when I haven't made a decision on what work coordinate I want to use. So if you ever open one of my files and it says 1 or 2 or 3 or 4 or whatever, I made that decision. And the only time I'd leave it at 0 is when I open up a program, I see 0. It's like, okay, maybe I want to run out to the machine, make sure I'm not using something. In this case, I'll set that at 1. That way my output will be G54. I always like to come back here and make sure, yeah, my model's not selected, right? So make sure my model's selected and we're good. Just kind of a troubleshooting tip. If you ever have a weird stuff, especially with 3D toolpaths, and you notice, just first thing you should do is go to the setup, make sure you have the proper body selected. Okay, and then the second setup's easy. We just do another one. We're going to do a model box point on this one. I want it to be this orientation. So I'll flip the Z, flip the X, and I'll put this guy right down there on the model box point. So again, this is going to be against my stop on the X. This will be my stop and my hard jaw in the Y, and then I'm going to have it sit on the parallel surfaces or surface. Stock, we're going to do from preceding setup with continue rest machining. Here, we're going to do 10002. We'll call this second op. And then I'm going to output this to, we did 54 in the first one. So we'll do 55 on the second one. And we'll hit OK. So my setup's ready. If I didn't talk through that, it would have been a lot quicker. But the nice thing with this is now I've basically micromanaged. I already have the stock, so I have to use this stock. Toolpaths should probably come up with something pretty similar because I have my kind of preferences set up like that. But this will be exactly what I want. And then when I get it back from Toolpath, I don't have to worry about resetting any of that stuff. Let's just save this thing real quick. I'll just say stock ready for Toolpath. Okay, and then we'll just send this sucker over to Toolpath. And then here you'll see the difference from that last one I showed. This is asking me, hey, do you want to send it over with these two setups? I'm going to say yes. So now it's coming over. My guess is it's probably going to take about 2 minutes. So as it loads up, I'll kind of talk through what's happening as it loads up. And maybe we'll run over and take a look at the first one I sent over without the attached setups. So this is popping over. Everything looks good so far. It'll take a minute or so to look at the setups. Let's go back over here. You can see all the overview, setups, tools, strategy, and estimate tab are all ready to look at. And it even says copy and ready to send back to Fusion. So we can take a look at the stock, right? So I said it's probably going to be pretty close to what I wanted. And you can see the stock size is 6 inches and basically a 1/16. And the Y and the Z are exactly what I would have already set up. It's probably offset a little bit less on this side than on what I set up before. But the X is a little shorter on the X, but I know the material I had, which is why I went through the extra step to define the stock. So let's just take a look at the part real quick. You can see we have a 99% machinability score, saying 99% of the surface area is machinable, and these numbers here, they're showing not machinable with my cut config, right? So my cut config, this is real tools in my shop, the way I want to set them up. And we can maybe go over that in another video, but I have a library and a cut config with different roles set up. The cool thing is in that I have a recommendation, tool catalogs that I said, hey, if I don't have the tool, go take a look at this. So with that, I have a couple tools recommended. And if I click here, you can see, if I flip over, zoom back in, you can see all the tool accessibilities are these tiny little pockets for my engraving. I do like to engrave this, but I don't want to actually make pockets. I'll show you how I do that. I'll show you how I do that in Fusion. Hopefully I remember. But if I wanted to machine those, I would just hit plus and plus and then regenerate that. And that would give me, you know, these machine pockets with, and tell me basically what tools I have to go buy. So the setup's pretty basic. It picked the same first setup that I picked. It picked the same second setup that I picked. Cool little pro tip I learned recently. If you're on one of these setups, instead of going down through here to see kind of, I just want to know what's machined on that first setup. If you hit setup 1, all of that is machined in the first setup, and that's not the same thing. If you go here, click on the setup, and that's what's getting machined on the second setup. So that's nice. And you can see here's all the pockets that's not getting machined because we didn't add those Harvey tools. So in the tools, here's my tool list. So tool 1, that's my favorite face mill. Tool 2, that's kind of my go-to rougher finisher. There's my Keyseat cutter. Tool 7, tool 36 is my 1/4 inch 3 flute. It's got 60 thou tip, you know, corner radius. I have another flat end mill. This guy's my favorite rougher, and we got, you know, a couple different tools here. So strategy, this is where if you want to see like, hey, what is this super swift carb, you know, rougher doing? Well, that's what it's going to do. And then here's what your finisher is going to do, and so on. Estimate, if I was making one of these with my presets, it should be 135 bucks. So this should be done by now. So we would overlook at the same thing. The only difference here is that this is with my exact setup. You can see how we have a little bit extra material on the sides, a little more offset on the bottom. Same tool recommended, right? So let's just hit copy the part key, and then we'll go back over to Fusion and hit OK. Now we have a decision to make. Do I want to import into a new document, you know, just create a new document, or do I want to import it into the current document? I'm going to just dump it into here. I already made the setups, just add the toolpaths to that. So we'll do import into current document, and that'll take a second to come in and add the toolpaths to my setups and then start calculating. You know, we're getting better and better and better on the toolpath automation. I'm pretty happy with it. I don't think I do any parts now that I don't put through Toolpath first as a, you know, an accelerator to get me started with all my roughing toolpaths and finishing toolpaths and all that kind of stuff. So if I expand these, you can see we have a nice roughing toolpath here. I'll do a face with that tool. We'll talk about this, you know, making these changes in a second. But so far everything looks pretty good to me. I see some things I want to change. But our goal, I mean, there will be a day that we're knocking this stuff out of the park and you'll just do a quick simulation and run it. But our goal is just to be a big accelerator for now. So on this side, what I see is that it basically did the face and did the chamfer. We're gonna add engraving there. And then on the first side, the main thing I saw, there's some micromanaging that I'll do along the way. But the main thing I saw is for now, Toolpath is only doing essentially 2D contours for Keyseat cutters and slot mills, slitting saw type tools. It does a really good job of breaking it up to make sure you're doing the right depth, right? Some people kind of struggle with that. But I know that that tool won't handle this just plowing in there and plowing out. So we're going to add a 2D adaptive so we don't overload the tool into those corners. And then we're going to add an under chamfer here, chamfer here, and chamfer there with a thread mill. So it won't be a 45-degree chamfer. It'll be a 60-degree chamfer, but I'll show you how I do that. Maybe I'll even show you how to store it as a template so it's really easy to use later. So with that, let's get started. So there's really nothing wrong with starting off with this 3D adaptive. There's nothing really wrong with that, but to be honest, I want to do the facing ahead. Sometimes it's easier to drag down. I want to just start off by facing with my favorite face mill. So I'm just going to change this to this face mill with my finish feed rates. I'll hit OK. So that's a quick change. Let's just regenerate this. Now, this is using tool 2, which is a flatten mill. So that's nice. It doesn't go very far below the part. If it did, I would change it because I already told you I can't go below that. We're holding on to 125 thou, so I can't, and I need 90 to really hold on to. So I can't go past the bottom by more than 35. Here's the finish. So we have tool 2 rough and finish, which is great. Tool 11 does that, which seems fine. We'll regenerate that. Tool 11 comes in here to do a wall finish, and then it does a floor finish. Knowing that the tool's wide enough to do both and just the wall finish, I'm going to delete the flat machining. The Toolpath will make that better here, you know, in the not too distant future. But for now, we do a flat and a wall and pretty much everything. So on the bottom height, we gave it 1/10, basically stepped it up 1/10 so we don't drag on the bottom. And then I just want to make sure we didn't do the same thing on stock to leave, so I'll turn that off. So what I did is I changed the bottom height to reflect this bottom, and then I got rid of the stock to leave there too. So deleting the flat was just saving a little bit of time. And this is an example where I'm gonna let it be. I'm gonna let it do the walls and then let it finish the floor. So that works out really good. And then I'll let it chamfer, and then I'm gonna fix this. And then we'll add those under chamfers in a second. So the first thing I wanna do is I'm going to right click and create a derived operation because I want to reuse some selections, right? And then I'm going to do 2D adaptive clearing. Now let's just hit OK and see what we get. Okay. So that's actually not terrible. We could actually run that, and then I bet right here we would have a problem. But we're also cut a ton of air that we don't want to cut, right? So let's edit this, go to geometry, and that blue kind of shaded area, it thinks is all the material it needs to cut, because this is kind of just a dumb 2D toolpath. So we'll go to stock contours and say, hey, actually, let's deselect that. This is actually the only area you have material to cut. I want to break up each side separately. Now I could delete this geometry here, but I don't need to. So what happens if we hit OK now? Okay, so that does a really good job, except I see some problems. You can see right here is that's gonna lift up. If I go to simulate, if I go click right there, that is going to be a problem right there, right? It's going to gouge my part. And that's the geek tip side of this video, is I'll show you how I deal with that. There's a couple problems here actually. If we look, it's lifting up here and it's lifting up here to get out. So I want to force it to stay down a little bit longer. So let's go to edit, linking. I only really want it to come out once. First thing I'm going to do is get rid of the vertical lead in radius, lead in, lead out radius, make that 0. And that way it doesn't, ramp out. And then I'm just going to change some stuff here. So my no engagement feed rate, my machine goes up to 800. This is just the repositioning. So I like to make that. To be honest, I would right click here and save as user default. That way I don't have to change it every time. Lift height, I don't need no lift height. I want to just stay down. Least stay down levels, my default for this is 70. So I'm going to save that as my user default. 70 just seems like a good kind of balance for me. And then my maximum stay down distance, like how far do I want it to stay down for retracts and repositions? I kind of save this part to part. This thing's 6 inches wide, and I kind of want to force it to stay down as much as possible. So I'm going to make it 8 inches. So now what kind of toolpath do we get there? Okay. So now we do get a reposition over here, which I don't like at all, to be honest. Another part I did, it just went in, came out. I'm trying to think how I could force that to do that for me. Oh, let's just play with the heights, make sure we have that right. So let's do from selection. We're going to define the top by this here, but we're going to go down -5 thou. And then the bottoms of selected contours, we're going to go up 5 thou because I want to save those 5 thou for the finish passes. And then the next thing I want to do is turn off my stock to leave. Oh, no, I'm sorry. I want to make like a 10 thou stock to leave on the radial, 0 on the axial. And then multiple depths, I'm going to say the maximum I can go down is 250. Fusion will do a pretty good job knowing that it's got to be 360 or whatever this is. And it'll do one full depth and then the next one lower. Yeah, okay. So there you can see we have one entrance here and one exit there. But that exit, if I go to simulate, is going to be no good, right? It's coming up through the part. So we have to find a way to force this to exit over here and then come up. And stick with me for a minute and I'll show you how to do that. It's a total, to be honest, it's somewhat of a hacky workaround, but it's pretty, I think it's a pretty acceptable workaround for the 2 or 3 times I have to do it a year. So what I just did is I right clicked and I duplicated that toolpath because I want to reuse everything I just did. And the only thing I need to change is what defines the stock. And to be honest, maybe I could have done that with one toolpath, but so the retract, we still got one retract and it's over here. But let's just duplicate this one more time and then see what happens if we get, if we combine it into one. I don't know why I was predicting we'd get something kind of wonky because I saw, oh yeah, I did the wrong thing here. So I want to pick that and pick that. And the blue, whenever I see blue like that, I get nervous that something wonky is going to happen. It's probably fine, to be honest, but I don't like it. So I'm going to delete that. We're going to go in and manually edit code to get our lead outs where we want. And I just want to make this as simple as possible to edit. So I'll show you how to do that after I show you how to do these kind of under chamfers and whatnot. So this is my Toolpath account. In my personal account, I have templates saved. So hopefully I'll remember to show you how to save this template. But let me show you some pre-work I did ahead of time, right? This is basically what we're going to do is that we're going to come in here and we're going to use this chamfer mill to chamfer both the bottom and under chamfer. So let's mirror this thing real quick. We're basically going to do that. We're going to chamfer under that edge and we'll just use it to chamfer this edge too, because then I can kind of get under this and down over here. And my side mill, honestly, I can't find my side chamfer tool. I'm in the process of reorganizing all my tools out in the shop, so I think I just misplaced it for a short time. But so we're going to teach you how I would do this and this. A couple things we want to pay attention to is the width of my chamfer mill is 40 thou. We have a 60-degree angle like every chamfer mill I have. And then this is, let's say we have a 10 thou chamfer. And we actually want to, we're not going to get the 45, right? So we want to, in the Z, we want to have a 10 thou chamfer. So I just made that coincident. And I'm willing to kind of go over, in this case, it'll be over in the Y and X, right? So we have 20 thou, we have 5 thou. I just kind of modeled this out, 5 thou. We could trig this out pretty easy. I just wanted a visual. So we have 5 thou there. So really what we need is this number here, 26 thousandths. That's basically from here to here. Okay. And then we also want this distance from here to here. So that's 15 thou. We're going to offset it in the Z 15 thou. And then we're going to offset it in the radially 26 thou. Okay. So let's go back. 15 in the Z, 26 in the radial. Okay. So how do we do that? I'm going to go to 2D contour. I'm going to go try to remember where I have this chamfer mill. Let's see if I put it in here. I feel like my reading skills get way worse when I know I'm being recorded. Chamfer mill, chamfer mill. No, I was looking for chamfer mill. What I meant was Threadmill, right? So maybe if I actually look for Threadmill, it'll be easier. So here we go. Here's my Threadmill that I want to use. What I'll do here is I'll just pick this edge. I'll pick this edge. Oh, you know what? This isn't going to let me do this. Yeah, so I forgot. My crappy hack is in my tool library, and this is all hack stuff. Fusion should let you do this. I created a form mill that mirrored. I just trying to remember where I put it. I created a form mill where here we go. No, that's not it. I created a form mill where, here we go. I created a form mill that matched my thread mill because Fusion won't let you use a thread mill to side chamfer with, which is complete garbage. Fusion can do better. I've requested it, but so now when we come here, we can do this, we can do this, we can do this, right? Maybe we want to break them up separately because we're going to have to shorten our leads so we don't gouge these parts. But okay, so now we're gonna go to, this is where I adjust how much we want to step over and down, right? So we're gonna go stock to leave. And remember, we're gonna go radially 26 thou, axial offset of 15. Oh, we lost that. That sucks. So if we go here, we go 4 mil, I have this guy. So we'll make those selections one more time. So we're gonna go here, 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 and I'm apparently need to rethink how I'm working. We need to do the undersides first, right? So we'll do the undersides first, and then we'll do those other ones. So we'll do passes, and we'll do stock to leave, radial, negative 26 thou, and then we'll do axial, negative 15. And let's see what that gets us. So the first thing I care about is, am I hitting the chamfer the way I want to hit my chamfer? Don't worry about that big gouge there. Let's turn off stock. And I went the wrong direction, right? I went down 15, and yeah, so what I really needed to do was go down, let's look at this, right? I screwed up. So I needed to go down 20 and then another 5. So half the tool is 20 and then another 5. So I should have been 25 thou below that edge that I picked. So let's go back and do that. Negative 25 thou. Did I do that right? I think I did that right. The key here is to save this as your default, so you only have to think it through and verify it once, and then you just reuse it over and over. Yeah, this is what I was trying to do right here, right? So I got this 5 thou below that, and then I have a nice, from here to here is 10 thousandths of an inch. So that works out great. Now the problem is that I'm gouging the crap out of this part here. So how do I know how much to look at this? I want to avoid this thing by, if you didn't know this trick, if you're in simulation, for one, you can click on things like this, and then you can left mouse click and hold and just kind of drag it through the toolpath. So what I really want to do is I want to get this thing real close to that wall right there. I'm going to get it in like a contrast area. Right there is about where it touches, right? If I drag it out just a little bit from there, I have clearance. So how do I know how much I just moved it? Well, if you go to info, so check this out. This is 4" 80 thou. And if you go back to this point right here, that's the beginning of the toolpath, right? So 4" 80 thou. So this is 4" 175. So if I go to my calculator, I go 4.175 take away 4.08, that's a 95 thou difference. So if I just move the toolpath this way, 95 thou in the X, I'll avoid gouging this here. And these are all the same radius, so that should be good for everything. So what happens if I go here, go to geometry, double click on this, and go negative 0.95, does it on both. So I just did a negative tangential extension of 95 thou, negative 95 thou. Okay, so let's verify that. So if we go simulate, now when I come in here, oh, I should also kind of share something else. But anyways, that is a really nice gouge free until it has the lead in, right? So if I go to this point right there, I have a really small window of not gouging, and then I do the lead. So, and I'm jumping around a lot, but if I go to edit and then linking, now what I want to do is I want to turn in that lead in radius to 0, leave the sweep angle to 90. Now we can leave this or make it even longer, but then we turn on perpendicular. And what that does is gives us this very straight, lead in, so that we don't gouge on the lead in or lead off. So my intention of these, Geek Tips videos is to show you, what we're doing at Toolpath, but also like, Toolpath for a while isn't going to be your 100% solution, even for some of these really simple parts if you want your parts to be awesome. My hope is that Toolpath frees you up from picking and clicking all your other stuff so you can do, just make your parts super rad. So like this, we have a real tight chamfer really close to that edge. So that's how you save that. Now what I'm going to do is I'm going to come in here. I'm going to say store as template. I'll say tool 30 chamfer Threadmill. Okay. So watch this. I'll delete this. And then now I'll come up to the setup and say create from template. Create from template. Tool 30 under chamfer Threadmill. And look how easy this is going to be. We edit this. Go to geometry. Fusion has a problem. It should not be thinking there's open chains. It should just clear those out, but you can clear them out. Click on this, life is good, and then you have that. I'll save you the simulation, but you can trust me that that's done and awesome. So now if I duplicate this, edit this, look at the stock to leave. So we went down 20 to get to the center and then another 5, right? Now we're going to be using this for here, and might as well do it there, but we're really looking to get under this, right? So now we need to move it down 5 to put it on center, right? I mean up 5. That'll put it on center, and then we go up another 5 above that. So now if we go here, now if we do negative 15, that's kind of what I was showing you earlier. That should be great. So simulate. Oh, I didn't do that extension, right? But if you look here, this is where we want it to be. Okay, so now that you know that the chamfer mill is where you want it, now we have to go shorten the tangential extensions and change. We shouldn't have to change the leads, just change these, right? So we'll do negative 95, negative 95. And just for thoroughness, I can simulate that. Now, if these fillets were different size, we would have to, so we have a super nice clearance there, right? If these fillets were different size than what we did before, we would have to change that a little bit. But I designed these, so I use the same fillets. And we have a super nice, so it's a nice way to, use the tool you already have. Okay, so that's that. I'm pretty happy with this part. The problem is if we posted it right now, we would still have this gouging situation. So how are we going to get out of that? This first thing, remember, so we're going to retract here under that shelf. We're going to retract there under that shelf. So that's a problem. So what I'm going to say is, remember, our work coordinate system is 1/8 of an inch off of this and 1/8 of an inch off of this. Yeah, so 125, it's actually 62 thou, right? So it's 1/8 of an inch is both sides, 1/8 of an inch this side. So it's 62, 1/16 of an inch off this way, 1/8 of an inch off that way. So what I'm actually going to do is come over to the design side, and I'm going to put a point right there first. So we're going to do up here, we're going to make a sketch, and then we're going to drop in a point where our work coordinate system is going to be. We'll dimension this, which is 0.0625, and 1/8 of an inch there, right? Next thing is I want to pick where I want my tools to retract. They're both 1/2 inch, not both, it's one tool. It's a 1/2 inch tool. So just model up not model, but I'll sketch up real quick where I want them to be. Let's say I want this guy to be roughly there. I want this guy to be roughly there, right? So let's do our Y dimension for this. So that is, we'll just round up to 1.375. And then let's see what happens if we go 3.5. Seems good. What happens if we go 3.625? That's not good. So 3.5 it is. Okay. So the intent here is that we go to a position that we know we're not under this shelf here, right? And then same thing here. We'll do X, just make this 2.5, and then Y, 2.25, okay? Do I want to flirt with this, call this 2.375? Can. Yeah, let's trust it. Let's trust it. This we decided was too close under there. So, okay, so that's that. Now I can write those down. I'll probably screw up writing them down. So here's a little trick for you. You can come here and maybe I'll put this, I'll call that retract sketch. I'll right click there and I'll show the dimensions. So you can only do that from the browser. You can't do that down here in the timeline. So now when I go back to the manufacturing side, those dimensions are still shown. Okay. And then now what I want to achieve here, first of all, I want to make sure that I'm not doing the finish pass before the roughing. So I'll drag this down below the two roughing passes, right? So I have an adaptive, and a finish. I'm happy with that. And then what I want to do is I want to create a stop, because remember, we're changing the G code here. So I want to go create a stop under this and a stop under this with a little cheat notes. And the way I'm going to do that is I'm going to come up to setup and create a manual NC, and I'm going to have a stop, which is an M0 in the code, right? And then actually goes under here, and then we'll just duplicate that and drag this one down here. Well, I didn't mean to drag them both down. I just wanted to drag this one in between these, right? So we have a manual, we have an adaptive, a stop, an adaptive, and a stop. I'll duplicate this and then change this one to a comment. And then now let's just confirm real quick that this adaptive is on the left side, and that's the one I want to retract up here. So we're going to just move it from being under to not being under, and then in a straight line, and then we'll retract. So in this comment, what I'm going to do is I'm going to put in the code that I want to. I'm going to say G1 for a straight line, and then I'll do X 2.375, Y negative, because it's negative, 2.25, right? So that's 2.25, 2.375. Those match, we're good. And then here, I'll duplicate this. I'll edit, make this a comment. And then now, G1 for a straight move. Do X 3.5, Y negative 1.375. Hit OK. So now how the heck do we get that to turn into code, right? So I'll go to sketches. I'll just hide dimensions. So those are gone now. I'll say hide. You know what? Let's see if this works. If I show dimensions, what happens if I hide the whole sketch? Yeah, that's what I should have done. So back to manufacturing. So now how do I get this to the code, right? How do I get these changes to the code? Let's save it. I'm ready to post. I would simulate it first, right? Make sure everything worked good. There's a collision here. Yep. There's a collision here. Yep. We knew about those. Another one. Okay. This is just showing. Did I pick? Oh, we are too close. So we need longer leads there. That's good. I'm glad I caught that. So we need these to have longer straight leads. So go to linking. Let's make this, I'll just make it 100 thou to save, not 1 inch, but 100 thou. And I'll do the same thing here. Now you guys might be screaming. Into your YouTubes. Create from template T30 under chamfer threadmill. So if I came here, duplicate that. This kind of sucks. That this is a bug right now. You have to clear that. Okay, so now I have this empty toolpath with no geometry selected. Now I can do store as template, and then I can come here and say T30 under chamfer threadmill, and that'll override it if I got the naming right. Yep, and that'll override it. So next time it has bigger lead-ins, it has everything that we changed, and we don't have to clear the geometry. Okay, so now what we want to do is we want to post this out and make those G-code changes, right? Do we want to simulate? Turn stock on. Let's just simulate real quick. Speed that up. Make sure that the only collision we're getting, I always like this guy to be on tail. Make sure the only collision we're going to get is there with that, which we expected, and there, and nowhere else. So we have this nice, under chamfer here. We have this really nice chamfer here, I think that looks wonderful and everything's good. Before we change and make those code edits, let's make a quick edit over here. So I have a template set up already to create from template, T8 engraving. I like to come in here, just pick my geometry so we get a good engraving in a way that I know I like to use. I don't have to remember my height setups and all that stuff. With that engraver, it just works great. It's a little Harvey engraver if you guys care. And you can just engrave at a 1/2 thou or 3/10 or something like that and just get really, really nice, fine, detailed engraving. In this case, I think I have it set at 2 thou, or 2 thou is about as deep as I would go. So then if we do a simulation here, sometimes I'll turn the model off. You can see, can you see? Let's, maybe we'll do material. Yeah, it's not showing up really good because the tolerance on the accuracy is not that good, but it turns out exceptional. Okay, so now it's time to post. So let's right click here, post, put this in my downloads folder. All this stuff is my normal stuff, and posting the first op. All right, so I have it automatically open in whatever this is called, VS Code or whatever. I also have the Fusion kind of add-in that color codes everything. So we have a couple things we can do here. We can copy the whole thing. I would probably make the edits here, but we can also go to NC Viewer, which is kind of fun. And we can paste all this into NC Viewer. And the cool thing with NC Viewer is when we make the changes, we can plot it, right? So I can show you the changes. So remember, I had an NC manual NC to do an M0 stop, right? So if I go Control F to find, I think that's Control F for find, and then did a M0, it'll find that M0 that I put in there with the manual NC. M0, if you didn't know, is just it's a stop, and so the program would stop there. And then in parentheses, I have those coordinates I put in, right? So I'll copy that. And then if you just walk your way up, this is the retract, and this is the last G3 that it made. So after the G3 and before the retract, I want to add that line of code right there. So let's undo this real quick, and we'll turn on the plot. And let's see where the tool is. Okay, so the tool is, we can kind of go backwards, right? So the tool is here. If I just go line by line, the tool's here, it goes here, it goes here, and then it goes up. And we know that it's under, right? We want to come over this way. So now if I hit enter and then add that, I think I have to turn the plot on and off, right? So now I go here, did I mess something up? Okay, if I plot it, I'm here, I'm here, I'm here, I'm here. What's happening? So 2.375, negative 2.5. That's not enough. I don't feel like that's working properly, but we know that it's enough. Something's going on with this other line of code here. Let's go check out Fusion, make sure I didn't get those numbers wrong. I'm not here, we're gonna go here, we're gonna come here, go to design, we're going to turn on the visibility of that, and we're going to look at it like this. So we're going to go negative 2 1/4, positive 2 3/8, negative 2 1/4, positive 2 3/8. Something's wrong with the backplotting, I think. So the Y basically doesn't change. X basically doesn't change. If I change this, so I did something wrong, right? Yeah, see, that's not changing now, so I have to... Something's working not right. Okay, so now it's working. What happens if I change this back to 375? Yeah, you don't see that change, do you? So there's something going on with the plot that doesn't add up. I mean, it's going the wrong direction. I'm screwing something up. I apologize. I'll waste your time. But that actually kind of shows the value of NC Viewer, right? So NC Viewer is a company that our friend Xander developed. And you can kind of see how it walks through there. And I can even go negative, 2.5, and then when we come back to here, I have to turn plot off. Yeah, so you can see it change to here, right? That's probably closer to what I want it to be to get really out of the cut. Sorry for the confusion, but let's push forward. I would bracket this, or not bracket it, but put that in parentheses. I would copy this, and then, no, actually I would copy this, search for the next one, and then before I move, I would copy this. Okay, so now we get to the same point here, before it makes that Z move, I would do this, and I would turn the plot on, and back on and off, and then you can see how it makes that move there. Okay. So we'll search for the next M0. I wonder if clearly my brain's not working right here, but it does show the value of the back plot. So that's the first M0. We already made those changes. So this is the next M0, and we want a line after this, right? So the line after this is going to be this. We might exaggerate that a little bit. I think I'm getting too close to these values here is what I'm thinking. Or maybe I just totally screwed up the... It actually looks fine. That's what I want, right? Is to make that move. So we'll stick with this. I'm screwing something up on the other one, and I apologize for wasting your time. I like to put this in parentheses just so it doesn't stop my program in the middle of running it. You can see how it makes this move, kind of off the part or out from under the part before it moves up. Okay, so then we're going to copy this to find the second instance because we're taking 2 Z passes, right? And we'll just copy this before we move on. That way when I find the second one here, I can just hit enter, copy that sucker there, turn the plot on and off, and then come back, make sure it takes that move right there. That's the move that we want to make before it goes up. So I don't know what happened with that other one. That kind of bothers me. And then from here we can hit save. We can hit copy, we can move over to this if we want, replace the whole thing, however you want to get the code saved. That's how you can do it. You can hit Control F, search for M0. Here's our changes here, here's our changes there. So that's how I got it to work. Man, I screwed up the explanation of it, but I hope that's helpful. I do this probably once a year, maybe twice a year, that I find that I have a Keyseat cutter kind of stuck under something. And I used to bang my head against the wall, but this is, once you get into kind of the workflow, it works pretty good. I'm a little bothered by this. I'll have to go back and figure out what really I'm doing wrong. Oh, I just figured it out. Yeah, I didn't dimension it up to the work coordinate system. So that's my bad. Yeah, I did it to the edge of the part, not to the work coordinate system, but I did it right on this one, right? That's a bummer. Actually, I'm all over the place. I did the Y wrong on this, but I did the X. I just screwed everything up, so I apologize. What I should have been doing was dimensioning it back to the work coordinate system. I guess that's what happens when my brain goes bad. My head's probably not that great anymore. But the key here is an M0, so it's easy to search for. And then you can, just put this in as a comment so you can copy and paste it if you get the right dimensions in. So with that, I'll stop taking your time. I really appreciate everybody's time. Check out Toolpath. It's becoming a really big accelerator for me on the cam side. My hope is it saves a significant percentage of your mouse clicks, so you can focus on kind of the harder stuff like that, making sure you get good chamfers, making sure your tools aren't doing stupid stuff. If you need to massage it, you can. Give me some comments about what you would like to see different. If you want to see me focus on something specific, call it out. I need to get into my tool cut configs, my tool libraries and cut configs, and kind of share how I've managed. I'll show kind of real quick how I've managed my cut configs. What am I doing here? Pull that down. Yeah, I can show how I've kind of managed my cut configs, all my roles, to help kind of automate my cam quite a bit. So I hope that's helpful. Share some comments. Is this good for you guys? Would you like something else? I'm gonna try to do, one a week, maybe two a week. I'm gonna be machining quite a few more parts for Toolpath in the garage on my Haas machine. So I should have lots of cool stuff to do. Talk to you guys later.